Welcome and thank you for joining this Fluke Thermal Imaging web seminar. This session focuses on the basics of thermography. We'll start by defining what thermal imaging is, show you where thermal imaging is used, discuss some of the basic considerations, talk about the power of IR fusion, show you some of the commonly inspected items. There'll be a preview of the SmartView software. We'll discuss where to go to get help in choosing the right thermal imager, as well as a summary at the end. This slide illustrates how very different things look in infrared as compared to visual light like our eyes see. As this slide progresses, you'll notice that what actually you're seeing is the reflection of yourself and the others in this window. Keep this in mind as the presentation progresses. It's important to know that things do not appear the same in infrared as they do in visual light. Infrared is a wavelength within the electromagnetic spectrum. Infrared radiation is radiated thermal energy that cannot be seen by our eyes but can be sensed by our skin. As you can see here, the thermal wavelength or infrared wavelength is a longer wavelength than the visible light like we see with our eyes. Thermal imaging is the non-contact detection and measurement of temperature differences. From there we assign colors based on those differences. Thermal imagers allow for very easy inspection of electrical equipment, electrical circuits, mechanical equipment, heating and cooling equipment, the building envelope, such as building inspection, various electronics, and there are many other applications as well. Here we see the difference between looking at something with your eyes in visible light and looking at something with infrared. When using just your eyes, it is hard to determine the flow of heat or proper operation of this piece of equipment. By utilizing the thermal imager, this becomes much easier. Thermal imaging allows for fast, safe, and accurate measurements for objects that are moving or very hot, difficult to reach, impossible to shut off, dangerous to contact, and sometimes where contact can contaminate or alter the object. Utilizing thermography allows us to stop fighting fires and fix problems before they result in equipment failure. Benefits include increased safety, improved reliability, better assurance of repairs, a reduction in unscheduled outages, the commissioning of new installations, improved production rate and quality, as well as an overall reduction in maintenance and repair costs. There are three modes of heat transfer it is important to be aware of when utilizing thermography. The first is radiation. This is the transmission of electromagnetic rays through space. Every material that has a temperature above absolute zero emits infrared radiation. Conduction is the direct heat flow through matter resulting from physical contact. As you see in the picture on the right, the heat is transferring along the metal rod and will eventually burn your hand. Convection is the transportation of heat within a gas or liquid. Relate this to a home or office building. Cold air drops, so AC vents are high on the wall. Because warm air rises, heating vents are on the floor. Again, it is very important to understand the modes of heat transfer when utilizing thermal imaging. One of the major considerations when utilizing thermography is emissivity. This is the ability for absorbed heat energy to radiate or leave an object. You can relate this to standing in the middle of an asphalt parking lot on a hot summer day. The reason it feels so hot is because the black asphalt is very good at emitting almost all of the energy it is getting from the sun. This relates to the reflectivity of certain materials as well. As you see in the picture of the iron, the right side of the iron that is red is coated in a black paint, which makes it much more friendly to a thermal imager to get an accurate temperature reading. The left side, the blue side, is not coated and is very shiny and reflective, which leads to false readings. Be aware that even when you're dealing with reflective surfaces, there are certain ways that you can remedy those to get better and more accurate readings. Here are a few more things you must consider. First off is thermal gradients. Thermal gradients come into play when trying to inspect equipment with a large amount of fluid or lubrication in them. This lubrication oftentimes will mask the true source of a problem as the heat is distributed through the liquid or lubrication. Thermal capacitance relates to a material's ability to retain its temperature. This is why we are able to measure the tank level as you see here. Wind also plays a role as well. The temperature of an object decreases as the wind speed going over it increases. Angular variation refers to the angle at which you are inspecting something. It is always best to get as close to a 90-degree or perpendicular angle to the object as possible. Please note that heat transfer is always from hot to cold. Be aware of your surroundings as well. Many times hot objects behind you can transfer their heat onto the object that you are inspecting. There are some basic conditions that must be met in order to perform most inspections. First of which is having a direct view. You cannot see through doors or enclosures. Thermal imagers see only surface temperature, so make sure you have a direct view of the object you intend to inspect. Make sure you understand the present and future load conditions of the equipment. Try and inspect with the highest possible load, the minimum being 40%. Make sure that you're not inspecting a piece of equipment that just turned on a minute ago. Only qualified persons should gain direct access to live electrical equipment. Be sure to follow the NFPA 70E and OSHA regulations and requirements, and always wear PPE or personal protective equipment. There are two main types of measurements that can be obtained when using thermal imagers, the first being qualitative. Note that most of the measurements taken with thermal imagers are qualitative in nature. These inspections focus on temperature differences as opposed to actual temperature. In many cases, the temperature difference is sufficient to indicate abnormalities in electrical and mechanical equipment. Many inspections using thermography relies on comparing similar equipment. The second measurement type is quantitative. This focuses on precise temperature measurement. Due to slight variations caused by material properties and atmospheric conditions, as well as other factors, these temperature readings can be difficult to obtain. For this reason, again, most measurements are qualitative in nature. Resolution of the thermal imager is important to consider as well. The detector within a thermal imager is made up of a pixel array, as you see in the example in the left corner. As you move farther away from an object, each individual pixel becomes larger once it hits your target. Be sure that the pixel size is not bigger than the target you are trying to measure. To obtain accurate temperature measurement, the spot size must be smaller and fit within your target. Here is an example of where resolution comes into play. Depending on the resolution of the thermal imager, you may not be able to get accurate temperature readings from certain distances. The size of your target plays in as well. In this instance, we are too far away from this fuse to get an accurate measurement. By moving closer, we're able to get our spot size within our target and get an accurate temperature measurement. For more information on the field of view and spot size, please visit the Fluke website and check out the field of view calculator. IR Fusion is Fluke's innovative viewing technology. This allows us to combine an infrared and visible light image together on one display. IR Fusion reveals more detail and helps pinpoint trouble areas by relating the thermal image to our visual world. IR Fusion is only available on Fluke thermal imagers. Again, IR Fusion links a thermal image with a visual image, making it much easier to understand what you're looking at. It allows you to see the context of the thermal scene. It also allows you to read markers, labels, and text that are on or around your target. There's no need for a laser pointer with IR Fusion. Reporting your findings to others becomes much easier as well, as it eliminates the need to take a separate digital picture. IR Fusion also helps with the focus. As you bring an image into focus, the thermal and visible light image align perfectly. IR Fusion offers several viewing modes. Starting from the top left, we have the traditional full-screen infrared. Next we have a picture-in-picture with full infrared, as well as a color alarm. Color alarm allows you to set temperature parameters for where you would like the imager to display thermally. There is a blended infrared in full screen mode, as well as a picture-in-picture blended mode. The last option is a full visual mode. Please note that not all viewing options are available on board all imagers, but all modes are available within the SmartView software. Common electrical items include inspecting for a hot phase, overhead bus bar, substations, transformer cooling fans, a relay panel, and a fuse disconnect. Electromechanical and mechanical equipment includes an electric motor, hydraulic pumps, checking for belt misalignment, compressors, as well as bearings of all sizes. Within process installations, thermal imagers are used to inspect items such as the high temperature cement kiln, the level within tanks, to observe weld cooling patterns, as well as to detect a paper processing issue. When it comes to building inspection or building diagnostics, we can use thermal imagers to inspect for roof deck moisture, other interior moisture issues, insulation voids, to verify the installation of an in-floor heating system, as well as to check for air infiltration. The Fluke SmartView software is included with every imager at no additional charge. There is no license agreement and no costly upgrades. Since the imager stores all raw temperature data, as you see by the points indicated in the image on the right, there is no need to capture an image twice. As long as you have the focus correct when you capture the image, you can optimize and change just about anything in the software afterwards. The software also features a report wizard that makes it very easy to create nice professional reports. Here we see some sample screenshots of the SmartView software. On the left we have an example of the image edit function. This allows you to modify temperature range, color palette, the emissivity, background temperature, IR fusion blending level, as well as add markers and annotations. This also allows you to export the image and temperature data to either Word or Excel. On the right we see 3D IR. This unique capability allows you to view an image in 3D from different perspectives. It helps eliminate false positives and identify additional problems as well. Here is a sample of a report generated by SmartView. These reports can be highly customized, and again the generation is made very easy with the help of the report wizard. For more information, please visit the webinar dedicated to SmartView. The reality is that a thermal imager can be your answer. Fluke thermal imagers are very easy to use, point, focus, and capture. They will make you more effective, which means you'll spend less time putting out fires and more time taking better preventative action. You will find thermal problems, solve them faster, verify repairs, verify new installations, and the bottom line is save money. The investment can be minimal, but the potential for payback or return on investment is huge. And it also allows you to verify that a problem has really been solved.